Okay. So, after snow closure in our last class, people went ahead and good proactive work and got all the assignments done. Almost everybody. So I'm very pleased to see that. Also pretty pleased to see that you did pretty well with the transformations. As I said, I'm gonna move that. I think I already did move that to be due on Saturday. So if you want to do more on it, you probably can and improve your score. If it won't let you, then you could go to the half credit page and do problems and correspond to problems that you want to try to do. And I'll go through the details there and give you the score that you deserve. Okay. But as I said, I'm looking at the class as a whole. I have a lot of good answers. There's some confusion, as you would expect on an assignment like this, because it's kind of challenging. Okay. So here's the second problem on the test. Given the values of A, K, and H, what's the formula for Y equals A F of X minus H plus K? Well, that's easy, and I think just about everybody had it. So you just plug in the numbers. It's going to give you negative 2F of X plus 5 plus 7. And you want to write out all this stuff. You want to write out minus the minus, because it's really easy to screw up a minus sign. And if you haven't written this out and you get down here and it's wrong, it's going to be hard to trace why it's wrong. Okay. You want to make it easy to debug your solutions. So kind of emphasize that idea. Okay, so that's good. Now, that's a pretty straightforward substitution. I'm pleased to see people did well with it. Okay. What series of transformations takes the graph of f of x to this graph? Well, I got a lot of good answers on this. Okay. Now, correct answer would be I'll write it. Vertical stretch by the factor of 2. And then flip about the x-axis. Okay, I'll reflect through the x-axis, right? I say flip, it's a little more active verb than reflect. But you know what I mean, I think. Okay. Now you can do these in either order. So I just kind of group these as the first thing you do. If you want to flip it first, then stretch it, that's fine. Both of those are multiplications. We do multiplications before we do additions. Okay. So if you got them out of order, if you did this last, it's not quite right, but you have all the right steps. You just got to understand it makes a difference when you do your multiplication. You get a completely different graph if you do these things last after the shifts, the vertical and horizontal shifts. Then it's a shift left 5 units because X has been replaced by X plus 5. Some people are getting the sign of that correct. Okay. Another thing that makes me think that y'all are doing pretty well. Okay. And then shift up 7 units. Now I could say shift horizontally 5 units, shift vertically 7 units. And I usually do that. I'm going to get a little more vernacular with my words and say over and up. Okay. Uh, well, I gotta say left or right, but. Okay. Up or down. All right, now for these, there's 2 9s on the graph of f of x. What point will be in the graph of each? Well, let's say f of x minus 5 shifts all the points 5 units to the right. Just to be complete, all the points of f of x get shifted 5 units to the right. So 2 9 shifts to 7 9. I saw that in a bunch of papers. Okay. Quite good. At that point, I was already happy. And then I saw more rooms. Okay. And if you messed it up, well, take a lesson. What in the world? Right on the screen. Hopefully clean off. Okay. Now, what does f of x plus 5 do? With all the points 5 units up. So 2 9 shifts to 2 14. Again, I saw that significant majority of the papers. Okay. So very pleased. And you should be too. Okay. Now, five f of x is a vertical stretch by factor 5. Okay. That means that all y values are multiplied by 5 because that stretches things out vertically. Make sure you understand that. The 2 9 transforms to 2 45. You multiply the y value by 5 because what? F of x is the y value, right? So multiplied by 5, that y value is going to become 5 times as great. Then, and I'll do this down here. Your vertical stretch takes you from 2.9 to 2.45, right? Because again, vertical stretch first. Now, if there's a reflection, you can do it before or after the vertical stretch, but you have to do any reflection and stretch before you do any of the shifts. Number one. Okay, then horizontal shift is +5, so take that 0.245 and you move it to the 0.745, right? Because your x becomes 5.75 grays. Now, the 0.745 goes to the 0.752. I'm not sure I saw that on anybody's paper, but I didn't usually look that far. Okay, so I won't be surprised if I see it on some papers. Okay, but make sure you understand this. Okay, if you got these three, I'm pleased. Okay, if you got this one, I'm just ecstatic. Okay, but if you didn't get it, make sure you get it next time because you need to understand these transformations take place sequentially. You start at 2.9, you stretch it, gets you to 2.45. Then you shift it horizontally, vertically, doesn't matter, but we chose horizontally, and that took us to 2.45 to 7.45. Then you shift it 5 units vertically and 45 and 5 is 2. So that's 7, so I added 7. Should be 50, right? So correcting that error. Vertical shift +5 takes the y value, makes it 5 gray. So what we've done is we've taken whatever the graph of this function is. Well, I can draw the rectangle in which this function might be expressed. Let's just say we got this function constructed in some rectangle. Okay. Made an injudicious choice of where to put that thing. I'm not going to do a stretch it like the 1, 2 is too high. I'm going to do it down here. Here's our rectangle. And let's say our 0.29 is in this rectangle. Let's say it's there. Put it any place you want. You don't have to put a scale on this thing. Okay. Whatever shape the function has, this then by the stretch becomes vertically stretched by factor 5. All y values are multiplied by 5. And we will assume that this is the line y equals 0, which is the x-axis. Okay. Then this thing becomes 5 times as high. 1, 2, 4, 5. And it's going to be a little tall rectangle. Not going to get any wider. It's going to get a lot higher. Okay. So this point is about between 2/3 and 3/4 of the way from the bottom to the top. So about 2/3, 3/4 of the way bottom to top. Its x coordinate is going to change, but it's going to go different. Okay. And the rest of the graph, every point of the graph, there are other points on the graph. We're going to go into this rectangle. And then the rest is pretty simple. We horizontally shifted 5 units. I haven't put dimensions on this thing. Now we horizontally shifted by 5 units and a rectangle. Oops, over 5 units. Okay. And the point is now here. Okay. And then we move it up 5 units. So, but this is just schematic scale. Make sense? So if this is a 0.29, it immediately goes to 245. Then it goes plus 5 units in this direction, takes you up to 745. And then it goes from here to here, goes up 5 units, and it's going to end up at 750. Picture makes sense? Now, if this thing has a shape in there, but just choose to draw some kind of function like this, then what's the function look like when I get it? This is still going to look something like that. Yes. Then this is going to be the same thing. It's going to be 5 units higher. Makes sense? All right. Yeah, good idea. Easier. Just draw some lines. Fortunately, nobody got up and did an embarrassing dance in front of the camera like you usually do when this thing's over. Okay. Uh, so anyhow, uh, sorry for all that dead space. Uh, Okay, so let's make the cost 6 years from today. Well, where's the cost? Well, why is the cost, right? So it would be useful to write cost in dollars. And this will be time in years. Makes sense? So now you're asked, estimate the cost 6 years from today. Where's today? Today is here, right? Because if this is x equals 10, x is the time 10 years from today. If x equals 10 here, today is 10 years before that, which is right here. Okay. Now, what's the cost 6 years from now? Where is 6 years from today? Well, this is today. This is 10 years from today. Halfway between today and 10 years from today would be like here. And then 6 years today would be like here. X equals 6 on this vertical line. That's 6 years from today. Now, you're used to doing this. And we've done this with our constructed graphs. So it's going to be a pretty easy transition if you didn't already make it. Many people did. Okay. Now, if you got this line, what are you going to do? You're going to say, okay, I want to know what the cost is. Well, points in this graph tell us the cost at different times. The point that corresponds to x equals 6 is going to give us some information. Right there's the point on the graph where x equals 6. And we sketch ourselves the horizontal. It looks like y approximately equals 1. Now let's say it's about. Okay. That makes sense. Make sure you understand that. You're going to do a lot of interpretation because that's why this stuff is done. It allows you to think about things you wouldn't otherwise be able to think about. They might be important things. Okay. Estimate when the cost will be $16. Well, 16 is a little more than 15, so I'd say 16 is no about here. So those lines are inconveniently close, but that can happen. But there's the point. The cost is $16. Okay. And we sketch a vertical line, figure out what x is, right? Now, if x is 16 here, that's our x is 6 here and 10 here. So if that was 6, 7, 8, it's going to be a little more than 7. Now, if you take grafting instruments and measure things in my graph, I doubt if 7.3 is accurate, but you understand it's going to be a little more than 7. It's going to, you go halfway from here to here and you get here, And halfway from here to here is a little bit to the left. And halfway from here to here would be 8, and then halfway here would be 7, so it's a little more than 7. Let's say 7.3. Say a little bit more. This point tells me cost 17 after 6 years. It's his first record. This point tells me cost 17 after approximately 7.3 years. Okay. That makes sense. Well, that's important. Now answer me the question. Cost is $15 after 6 years, $16 after 7.3 years. How fast would you say that the cost is changing? Okay, there are a number of answers to this question, and any of those answers would be okay. Now, a lot of people didn't use this information. They just used it $16 after 7.3 years. And then went all the way back to this point section, okay? Still, those people were using the definition of average rate of change, okay? Now, I didn't say use an average rate of change, but many people did, and that's exactly what we're going to answer. The simplest answer cost goes up $1.3 in 1 year, right? Okay. I'm sorry, wrong. Cost goes up $1 in 1.3 years. My number's wrong. Okay. Those cost goes from $15 to $16, $15 to $16. So that's $1 per 1.3 years, which means $1 divided by 1.3 years, which is ballpark 0.7 dollars per year. That makes sense? It takes more than a year to go up $1. It's going up at less than $1 per year. Okay, Now, this fits into the definition of average rate, which many people use. That is the average rate of change of cost with respect to time. Okay. The average rate equals delta y over delta x. What's delta y? Y goes from 15 to 16. X goes from 6 to 7.3. Approximately equal to 0.7. Might actually be closer to 0.8. Figure it out. Okay. I can figure it out as 0.7, 913, so that's about 0.76. And 7.5, that's just 76. $18.76 per year because this numerator is in dollars and this denominator is in years, right? Does that make sense? Make sure you totally understand that. Okay. Now, some people maybe went back to this point and calculated the average rate between here and here. That would be okay. You'd have to estimate this point here. And it looks like that's maybe $8. It goes up from 8 16. And that's up $8 in 7 years. It gives you a little different slope than what we estimated here. Now, one thing about this, it's a straight line. Assuming this is a straight line, the slope's got to be the same no matter what 2 points you use. Okay. Now, I made estimates between 2 nearby points. I can't expect the ratio of those changes, since they're so small, to be estimated all that accurately, right? So if you take the actual slope of this line, it doesn't quite match this soft line. Maybe it's 0.76 and it should be 1.1 or something. Okay. But that's okay. Well, you're going to have problems of that nature in the thing on straight lines. Okay, I'll tell you a little bit more about straight lines. Okay, the equation of a straight line, everybody should be familiar with this somewhere in the recess. I'll take it out here. These are two kind of important equations. And they come down to the same thing. You could always solve this equation for y, and you're going to get something times x plus something else. Okay. I'm going to stick with this one. Okay. Oh, the slope intercept form, I don't have room to write out the word intercept. We can get this equation based on some estimates. Okay. Let's just take this point, which we pretty much know that point is 10, 20, right? What's this point? Well, if we divide this interval in half, I'm gonna say that's 0.8. Here's 0.8. Here's a point. Point. Y is 20 when x equals 10. So y equals mx plus b becomes 20 equals m times 10 plus b. We don't know what m and b are, but we do know that x equals 10 goes with y equals 20. Is that clear? So we can write this equation. Okay. Well, y equals 8 when x equals 0, so 8 equals m times 0 plus b. Well, I can isolate these two equations. They become 20 equals 10m plus b and 8 equals b. Okay. Now there are two things I can do with this. I can substitute b back in here. I make substitute 8 for b. B equals 8. Twenty equals 10m plus 8. Solve for m. Well, we have 20 equals 10m plus 8. We'll do the thing you like to do. Subtract 8 equals negative 8 equals negative 8. Right? This equation, or add this equation to this, we get 12 equals 10m. So m equals 1.2. Make sense? Now what's our equation? Equation becomes y equals 1.2x plus 8. Okay. Now, of course, you could go to the graph. And you could calculate the slope between this point and this point, just the rise and the run. The rise is 12, the run is 10. You divide rise by run, 12 divided by 10 gives you 1.2. But you can put it into the equation as we did and get it that way. Sometimes it's more convenient to do it one way than the other. Either way, you get an equation that tells us where every point on that graph should be. Okay. So now we have a function. And we call it y equals x actually equals 1.2x plus 8. This is a linear function. Off versus time. Try to understand every word of that, each to the wording. Because the meaning is in the words. Also in the pictures and whatever else goes on in your mind, because everybody conceives of things a little bit different, okay? So x equals 6. X equals 6 according to the formula, what's y? Well, we can take 6 and plug it in there. Y equals f of x, which is 1.2 times 6 plus 8, which is 15.2. What was our estimate? And x is 6 plus 15. You got when x is 6, you estimate it was 15, right? So our estimate pretty close to what the linear function would be given these 2 points. So again, using these 2 points, we found the linear function. We used the linear function to answer the question that we estimated and found out that our estimate was pretty good. Okay. Well, it's cost going to be $16. Okay, well, y is the cost, y equals 1.2x plus 8, where x is time. Solve the equation. 16, which is the cost we want, is 1.2x plus 8. Subtract 8 from both sides. I don't have room to do it all. But we're going to get 8 equals 1.2 x. We're going to get x equals 8 divided by 1.2, which is going to be 6 2/3. Approximately 6.7. Now, over here, when I did my estimate, I estimated 7.3. Okay. Now, that depended on me having the right distance between these 2 vertical lines, and then drawing a straight, having the right distance between these 2 horizontal lines, and then drawing an accurate vertical line. So there's a little margin for error there. I got 6.7, well, I should have got 7.3. Wasn't a good estimate. Okay. When things are really close, it's hard to estimate the distances accurately. Okay. If they're further away, it's easier to get accurate estimates. Okay, all that's important. You understand this process? You do, have this starting later functions and couldn't have any trouble with the assignment. Okay. Okay, very good. Have a great week. And I'll turn this camera off so everybody can dance in front of the